Hi everyone, so in this video I would like to give you some details about high resolution processes. This is just an introduction, and in the later videos you will see how to pattern in high resolution, both a general strategy that you can adopt to pattern in high resolution and a practical session where I pattern a high resolution stack. Here I just wanted to give you the main important information regarding high resolution stack, high resolution processing, and patterning. So you will find a lot of information in our NanoFrazor recipe book. Here I will just give you some highlights from the recipe book. So what do we talk about when we say high resolution processes? Then typically have a lift-off high resolution or high resolution etching. So for the lift-off, we deposit metal after we open our high resolution stack, while for the etching, we etch into our substrate. The high resolution stack that we use for both of these processes is typically the same. What may change is the underlayer. Typically for high resolution lift-off, we usually PMMA, MA, or PMMA, while for etching, try to prefer PMGI, but several materials can be used and you can find more details in the high resolution session. What's the most important thing to mention about high resolution process? Well, first of all, what is high resolution? Usually with these stacks, we can go down to features of 15 to 100 nanometer resolution. So resolution that is not achievable with a bilayer lift-off process. And one important concept to keep in mind is that the transfer process is a dry process. So we use RE to open our high resolution stack, while for the bilayer lift-off, we only use liquids. So it's a wet development. So high resolution stack, we usually refer to a stack that's structured in this way. So we have an organic transfer layer, for example, PMMA, a silicon dioxide hard mask, and a PMMA buffer layer, where on top we put a PPA layer. And usually this PPA layer is very thin. It ranges maybe from 15 nanometers to 6 or 4 nanometers. And we want to have a very thin layer of PPA because the smaller is the thickness, the higher is going to be the resolution of our process, because of the tip is going to make only very shallow indentation. So not having the tip geometry, conical geometry, making bigger holes because of its geometrical limitations. We're only using really the apex of the tip. So this allows us to make shallow indentations in thin PPA that then through RA process we slightly clean this pattern PPA area and PMMA. Then we open the hard mask below, and this allows us to then quite directionally etch into our transfer layer with oxygen. And then depending on whether we want to do a deposition or reactive ion etching, we have to perform a following step. So this is what we call high resolution stack. And we can find more details if we move into the section of the high resolution. So this is just to show you what some details that I was mentioning to you. And if you want to read and know more, you will find all the information that are required for the preparation of the stack. So usually which kind of spin coating speed you can obtain to prepare a 10 nanometer thick PPA on top, and also the hard mask preparation, which can also be spin coated with a pi bond or evaporated if you can evaporate silicon dioxide or other hard masks. So all these experimental information are in the recipe book, and they should help you in being more successful with these processes. So from the preparation of the high resolution stack to the evaluation of the hard mask quality, and to the etching of the PPA and the hard mask. Of course, since we are using a reactive ion etching process, then we need to tune our RAE respectively to our materials that we're using. So in this case, let's say we have PMMA as transfer layer, silicon dioxide hard mask, PMMA and PPA, then we need to know the etch rates with our RAE of PMMA, silicon dioxide, PMMA, and PPA to have a successful process. And it's very important to have a good control over the etching of the thin PPA layer, because this layer is very thin. So if our reactive ion etching is not well tuned and we burn it all after the first O2 and 2 plasma discom process, then we will not able to transfer anything to our substrate. And this is, again, very thin layer, so 10 nanometers can be easily burned with an etching step, especially if we're talking about a polymer. So I really recommend etching, the tuning of your reactive ion etching first. And here you can also find some more details about high resolution liftoff, the recommended thicknesses, and the opening of the stack and the liftoff process, with also some limitations. And in the same way, you can find some details regarding the high resolution etching. Lastly, I would like to also mention that at the end of our recipe book, in the appendix, we have some suggested recipes with the tool. Let's find it here. With the tool Oxford PlasmaLab RA80+, which we use at IBM for our processes. And here you can find some recipes that we use with the RAE, with this specific RAE. I will use them, if I were you, as starting point for your measurements for tuning your RAE, because then every RAE, depending on how it's used and which materials are being etched by it, can have different conditions. So maybe use this as a starting point for your etching tool, or as an idea for possible recipes that you can use with other etching tools. And you can find details about PPA etching processes, silicon dioxide, PMMA, PMGI, organic transfer layer, and silicon etch, as well as other materials. Also graphene and MOS2 if you want to etch 2D materials. So in general, this again was just a very brief introduction to high resolution processes and to the information that you can find in the recipe book. So I hope that you could read through this information before diving into high resolution patterning, which I have to mention is the most challenging patterning that you can do, because it requires a lot of mastery of the patterning parameters and how to tune them and how they affect the patterning in general. So in the next videos, we will also see how to pattern in high resolution, the strategies that I will adopt and that you can try to adopt and develop yourself. And also we will see a session where I practically pattern on a high resolution stack, showing you the differences between that and a fake PPA sample, both with SPL and with laser. So yep, this was just an introduction, and I hope that the next videos will actually help you to pattern effectively with your NanoFrazor. Thank you.